Simplifying polynomial expressions. So when you're simplifying polynomial expressions, you've got to combine the terms that have the exact same variable and exponent. So for example, if we have x squared plus x to the third power, you can't simplify that any further. It's just x squared plus x to the third because they don't have the same exact exponent. Same variable, not the same exponent. So let's look at this example right here. We've highlighted the terms for you, or Miss Wynn did, but let me show you what you can do if you don't have a bunch of highlighters or if you're just writing on pencil and paper, right? So we've got this expression here, negative 5x squared plus 5x minus 2x squared minus 8x plus 11 minus x minus 15. Phew. Let's go through this and let's find all of our like terms. So I see I have this negative 5x squared, so I'll underline it. Okay, and let's look for any other x squared terms. So I see right here I've got an x squared, so I'm going to underline that term as well. And then I see that I have this plus 5x. So I'll circle that one. It's just an x term. And then I look through the rest of the polynomial expression, and I see that I have this minus 8x and this minus x. So those are also like terms. And then I have two constants left. I have this plus 11 and this minus 15. So I give those a little squiggle, or maybe you can box them in, whatever is easiest for you to read or whatever you like looking at, okay? So now let's combine these together. When we have this negative 5x squared minus 2x squared, all you've got to do is combine your coefficients. So negative 5 minus 2 is where we get our negative 7 from. So this entire term is negative 7x squared. Then we have our x terms, our plus 5x, our minus 8x, and minus x. Remember that this minus x has an understood 1 in front of it, which is rewritten right down here. So let's combine those together. So we have 5 minus 8, which is negative 3, minus 1 more is a negative 4. So that's where we get this minus 4x from. And then there at the end, we have this plus 11 minus 15. That gives us our minus 4. All right. Now, if you're adding and subtracting polynomial expressions, if we give you more than one to just simplify, one method that you can do is you can choose to stack your polynomial expressions like you used to do in elementary school when you were adding larger values together. It is completely and totally up to you. It's just a matter of preference. Whichever way you like combining your polynomial expressions is fine. So just a key thing to remember when you're subtracting polynomial expressions, you need to rewrite those polynomial expressions, because when you're subtracting, this entire expression, this minus sign, has to get distributed to every single term. So don't forget that, okay? Let's go through some examples. So we're going to simplify the following expression. I start and I notice that I have a 2x cubed, 2x to the third power here to begin with. And I look through the rest of this expression and I have no more x cubed terms. All right, then I see I have a constant, a plus 5. So that's a plus 5, a constant. And then I also have this minus 6 right here. Okay, and then I look and I see I have a plus x to the fourth power. So let's give that a little squiggle. And I also have a plus 8x to the fourth power. And the only term I have left is this minus 3x right here, but it doesn't have any other like terms that go with it, so I'll just leave it alone. Now, when we're combining this expression or simplifying this expression, it's important that we write it in standard form. So remember, we start with the highest exponent. So I have an 8x to the fourth power. That's the term that I want to start with, 8x to the fourth power. Then we have our 2x to the third, and we have, oh, there's nothing else. It's by itself. It doesn't have any like terms. So let's list that next. It's plus 2x to the third. There's no sign in front of it, so we know it's a positive. So after the third power should come an x squared, and I'm looking and I don't have any x squared terms, so we leave that alone. Then we have an x term. I see that we have a minus 3x, so I'll go ahead and write out minus 3x. And then we finish off with a constant. Okay, our plus 5 and our minus 6 gives us our minus 1. All right, so we have an x to the fourth term, x cubed term, x to the first power, and then we finish with our constant. So that's in standard form, and we've combined all of our like terms. All right, let's look at the next two problems together first, and let's notice the similarities and differences. They're both addition. I see that we're adding both of these, and I have an x squared, an x, and then a constant term here. But in this second example, my values, my terms don't really match up. I have an x to the fourth here, but not here. I see I have an x cubed here, but not over here. I do have x squared terms in both of these. It's just a little bit harder to match up. So this is the problem where I'm probably going to show you stacking, okay? Maybe the problem at the top will go ahead and we'll just underline and circle and identify the common terms that we can combine together. All right, so negative 5x squared, and then I'm going to add to that our minus 8x squared. So I'm going to circle and circle. So negative 5x squared minus our 8x squared. I also see that we have a plus 4x and a plus 2x. And I have this minus 2 and this plus 1. So let's combine our like terms. Negative 5x squared minus 8x squared. That'll give us a negative 13x squared. Then we have our plus 4x plus 2x. That gives us plus 6x. And then we have our minus 2 plus 1. That just gives us a minus 1. Easy, straightforward, not so hard. But now I have these terms that don't necessarily match up. So let me show you what stacking looks like. When I start with my first polynomial, always look for the highest exponent, right? So I see that I have an 8x to the fourth power. That's what I'm going to list first. Oops. 8x to the fourth power. And then I look in this polynomial expression and I see that I do not have a cubic power. I don't have an x cubed. So I'm going to put in a placeholder. I'm going to say plus 0x cubed. So we have x to the fourth and then x cubed. And then I do have a plus 2x squared term. Then I look for an x term, and I see in my first polynomial expression I don't have an x term. So I'll put plus, let's use orange, plus 0 x's, and then I do have a minus 1. So I listed all of these terms in exponential descending order, right? They're going down, x to the first and then a constant. All right, now we're going to add to that all of these other terms in our second polynomial, okay? All of these other terms in our second polynomial. So let's start with our minus 5x squared. I'm going to place that underneath my x squared term. So minus 5x squared. Minus 5x squared. Then I have plus 7x. Okay, so I'm going to put that under my 7x term. Under my x term, so plus 7x. Remember, you want to line up your like terms. Then we have our plus x to the third power. So let's put it underneath our cubic like term, plus 3x cubed. We're just matching up our terms. And then we have here at the end our plus 4. So I need to put that underneath our constant, plus 4. So now we have all of our terms lined up and we can combine them together. 8x to the fourth power has nothing to combine with. Then we have 0x cubed plus 3x cubed. So I've got plus 3x cubed. So 2x squared minus 5x squared gives us our minus 3x squared. 0x plus 7x gives us plus 7x. And then, of course, we have our minus 1 plus 4 gives us our plus 3. And that's how you can use stacking to solve these problems when all of our terms don't necessarily match up. All right, let's look at the next two problems. They're both subtraction. These examples are both subtraction. Now, what's important to remember is if you're subtracting, you have to remember that you are distributing this minus sign to every single term. So let's go ahead and rewrite this first. we have negative 4x squared plus 4x minus 6, nothing different there. But all of these terms in my second polynomial have to be changed. Okay, all of the symbols have to be changed. Minus a negative really means plus. So we have plus 9x squared, that sign changed, minus a 3x, minus 3x, and minus a negative 2. That really means plus 2, right? Do we see that? This sign changes to plus, the plus 3x changes to minus 3x, and the minus 2 changes to plus 2. And why did we do that? Because we're subtracting this entire expression. Now we can go ahead and circle, underline, highlight, whatever it is you want to do, right? We have our minus 4x squared and our plus 9x squared. We have our plus 4x and our minus 3x. We have our minus 6 and our plus 2. So let's combine our like terms. What is negative 4x squared plus 9x squared? That gives us our 5x squared. All right, what about plus 4x minus 3x? That gives us just 1x or plus x. And then we have our minus 6 and our plus 2. That gives us our minus 4. And that's our simplified polynomial subtraction problem. All right, so let's do the second one with stacking again. Okay, so we're going to use stacking to simplify this as well. So let's look at our first polynomial expression. I see that the highest exponent is x to the 4th power. So I'll start there. So we have 6x to the 4th power. And I don't have a cubic term in this polynomial expression right here. So I'm going to go ahead and use a placeholder, plus 0x cubed. But I do have an x squared term right here. So I'm going to say plus 5x squared. And then I look and I see I don't have an x term here, so I'll just use my placeholder again, plus 0x, plus 0x, and then our constant on the end, that minus 9. Now again, this is a subtraction problem. So this minus has to go to every single term, in our polynomial expression. Every single sign is going to change. You must change every single one of them. That's what subtraction does. It means go in the opposite direction. So this 2x to the 4th power becomes a minus 2x to the 4th power. And I place it underneath its like term. It doesn't matter what order they're placed in. You need to put it underneath its like term. Then we have our minus negative 3x to the 3rd. That changes to a plus 3x to the 3rd. Then we have our minus positive x squared, 4x squared. So it ends up being a minus 4x squared. Then we have our minus a negative x. It turns into a plus x. And then we have minus 6. So take a minute and look at this. I want you to notice that 2x to the 4th power becomes minus 2x to the 4th power. Minus 3x cubed becomes a plus 3x cubed. Plus 4x squared becomes a minus 4x squared. Minus x becomes plus x, and plus 6 becomes minus 6. And why did we do that? Because we're subtracting this entire polynomial expression. Back here at the top, when we were adding our polynomial expressions, we didn't have to change any of these signs because we're just combining them together. Plus means keep doing whatever it says to do. Minus means switch directions, change directions. All right, so here we go. Let's combine these together. 6x to the 4th minus 2x to the 4th gives us 4x to the 4th power. 0x cubed plus 3x cubed is plus 3x cubed. 5x squared minus 4x squared gives us a 1x squared, or just x squared. 0x plus x gives us just our plus x. And then we have our minus 9 minus 6 gives us our minus 15. So again, you can choose to stack, or you can choose just to identify like terms and combine them either way you like. It's just a preference. Whatever you choose is fine, but that's how you simplify and add and subtract polynomial expressions.